Okay, now let us take 2002 problem which says that you have to find the positive integer just greater than this expression. Okay, 1.0001 raised to power 10040, that is 10,000. So you need to find the integer which is just greater than this. This is a very good question. I would say normally very few people will be able to solve this who know the trick to this one. Let's see, the power basically, what is the expression that we guys do? This is of this sort, where here n is equal to 10,000 and x is equal to 0.0001. If you see properly, what is it? X is equal to 1 by n, because x is equal to 1 by 10,000 because it's having 4 decimals. So basically this expression is of the sort 1 plus 1 by n raised to power n, where n is equal to 10,000. Okay, so this is the expression. So if I just expand this expression in the normal way, what it would be? 1 plus, let's see, just apply the formula, that will be nc1, that is n into 1 by n, plus nc2 is n into n minus 1 by 2 factorial, okay, into 1 by n square now. Okay, if I again go ahead, this will be n into n minus 1 into n minus 2 upon 3 factorial into 1 by n cube, and so forth. This will go on. Let's see, I can cancel this out. This will become 1 plus 1 by 1 factorial I can write, because 1 upon 1 factorial is 1 only. This will be what? 1 by 2 factorial into 1 minus, this will be n square minus n by n square, right? Which I can write it down. I can just writing it down here only. This will be 1 minus 1 by n. Okay, let's see what this will become. This will be n square minus n over here into n minus 2, which will be n cube minus 3n minus plus 2n upon 1 by 3 factorial is outside, and I'll take n cube. Okay, this will be 1 by 3 factorial into 1 minus, now what I can write over here is 3 by n square minus 2 by n square. Sorry, this will be n square, so this will become only n over here. So this is minus 2 by n square. Okay, and this kind of series will go on, like 1 by 4 factorial, again you will have 1 by 4 factorial over here, which will have something of 1 minus over here in terms of n. Now let us see why I am doing this kind of thing. Why I am doing this is because of a reason. Let's see why. We know that the expansion of E, what is the expansion of E first of all? Okay, let me just rub this off so that I can write the expansion of E over here. Okay, expansion of E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial and so on up till infinity. Okay, this is the expansion of E, and we know that E is a number lying between 2 and 3, so that means the number just greater than E, which is an integer, is 3. So if you compare this with this thing, we have 1 by 2 factorial, and this is 1 minus 1 by n factorial, 1 by n, where we know that n is equal to a very big number, 10,000. So that means 1 by n will obviously approach 0. So I can write this as, this number will always be, less than 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so forth. Why? Because I have assumed that 1 minus 1 by n will give me 1 only, because this term will be approximately 0, this term will be approximately 0 and so forth. So all the terms will be approximately 0. So this has to be less than this term, because this will be the maximum term this expression can gain. Okay, and we know that this is the formula of E, so that implies this term is less than 3. So the next big integer in this expression would be 3, which is the option D in this case. So this was I would say, one of the most difficult questions asked in AIEEE up till now. Unless until you know the procedure for this question, you will not be able to solve this one. So this was not at all an easy question. Just remember this, it might be asked in other regional examinations as well. So you should know how to use this trick in these kind of questions. Okay.